Thank you so much for coming. My name's Anton. This is my good colleague, friend, started as a partnership, now a good friend, Ron from CyberArk. And today we're going to be talking about scaling serverless with platform engineering, right? A blueprint for success. Now, it's important to mention that when I'm saying scaling, I do not necessarily mean what you think scaling means in context of serverless. It's not how you scale from 5 requests per second to 5,000 requests per second. It's not that kind of scaling. When we're talking about scaling here is how do you scale serverless engineering in your organizations, right? How do you get from a point where you have one team developing with serverless to a point where you have 100 teams developing with serverless without losing their efficiency? That's what we're going to be talking about today. At the very last slide, you will have a giant QR code that will lead you to a page with everything you will see today, including these slides. You'll have these slides in 59 minutes, roughly. Okay, so feel free to take pictures. Technically, you don't have to. All right, we got to start somewhere, right? And it always starts here, right? In the beginning, we have application development team and infrastructure team. So let's do a quick show of hands. Who's here on more on the application development side? Few people. More on the infrastructure, platform engineering. Ooh, you're in the right place. You're in the right place. All right, let's talk. So everyone is familiar with this model, right? It exists for ages, right? Application developers, they're responsible for the application layer. They write code in whatever language. And you have that infrastructure layer under the hood, virtual machines, databases, networking, etc., which is usually managed by this awesome team with many different names. Infrastructure, DevOps, operations, SRE, depends on your organization, right? Now, sometimes developers need to make changes to the infrastructure. As you develop new applications, you need changes in infrastructure. So who's here using ticketing system between development and operations, etc., right? It's pretty common. It's still pretty common. So application developers open a ticket using whatever system, change request, infrastructure team implements that change. And it works great if you have one application development team and one operations team. But at some point, you got your second development team. And then you have your third development team. And it continues and so on, so on, so on. Anyone resonates with that? Right? I think all of us know what we're talking about here, right? So it's not a nice thing to say, but at some point in time, we hit a place where that infrastructure team, without really wanting to get into this point, they're kind of becoming the bottleneck, and that's not a good place to be, right? No one wants to be, that team that everyone complains about, right? So how do we solve that? How do we solve that? Well, there are a couple of ways we can solve it. First of all, yay, shift left to the rescue, right? Now, shift left works, but the problem with shift left is that the definition of shift left evolves over time, right? And you can always throw more stuff into your development teams, right? So now you're also responsible for DevOps, and now you're also responsible for security, and now you're also responsible for sustainable, right? And now you're also responsible for picking the right model for your agentic application, right? So it's not going to scale for 100 engineering teams. You cannot just throw stuff to the left and kind of expect it to work, right? So another way is, since this is a serverless session, is you can start using serverless. If you have problems managing a lot of infrastructure, well, let's manage less infrastructure. Let's shift to serverless, right? I'm not going to cover every single bullet here. Since you're in this session, you're probably familiar with the idea of serverless, right? Minimized infrastructure management, right? But when you're moving from this world of serverless, your perception changes a bit, right? So you come from the world of traditional applications where there's a clean separation between application layer and people and infrastructure layer and people that handle that into this new shiny world of serverless applications, right? Where you might still have the infrastructure layer. It's pretty slim, but it's still there. It's not necessarily gone, right? You might still be using RDS, right? But most of your application components, I'm going to be using the term components here, are serverless. It's essentially a collection of loosely coupled serverless services like Lambda, ECS, Dynamo, et cetera, et cetera, et cetera. And we're hitting an interesting state here, right? Application developers and infrastructure people, they kind of start having this interesting conversation. Lambda function. It's kind of my application resource as a developer. I want to control it. But the operations people are saying, no, 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 no. We do it with Terraform, CDK, CloudFormation. It's infrastructure. We want to control it, right? And both sides, they have good intentions, right? No one is wrong here. They have good intentions, but a little bit conflicting intentions, right? So it becomes a conflict of autonomy that developers want versus standardization that the operations team want. Anyone familiar with this? Oh, yeah. Oh, yeah. So if we put it on a chart, right, and now it's going to be a little bit interactive. There are startups, and startups, they care more about autonomy, right? They don't need to do PCI, HIPAA, et cetera, certifications. They need to move as fast as possible. But there are also regulated, highly regulated enterprises that need that compliance because they cannot afford every single team doing things in their own way, right? It's super hard for regulated industry. So let me ask you a question. Let's take like 3 seconds. Where do you think you are on this chart? Who's thinking they're more in autonomy? What about the standardization? Probably most of you are thinking, oh, we're definitely having the right balance, right? We're exactly in the right spot. So the goal of today's session is to talk how you can get here, how you can get the best of both worlds. I'll be talking about different techniques, and then Ron will cover how they implemented these techniques and many more in their environment and speed up their development. To give you a little teaser, right, maybe a spoiler, but more of a teaser, they've managed to reduce time it takes to launch a new service, like from scratch, from nothing, from pretty much 5 months to 3 hours. That's like 99% improvement, okay? So today you'll see some of these practices from me in hypothetical and from Ron in practical. And again, all of that is open source on GitHub. Cool. Whoa, sounds great. Can you please be a little bit more specific, probably, right? You're wondering at that point. Yeah, let's be more specific. So this is what development organization commonly look like, right? That's what we call traditional ownership boundaries, right? You have application development team, they manage their code bases. Then you have operations people, infrastructure, operations, platform is the new fancy term, right? They manage a lot of things like CI/CD monitoring, et cetera. It's not like everyone is exactly the same. This is, general picture of this. Shift left brings this to this. You might have seen it, I called it Wild Wild West, right? Where essentially you're saying every single team is free to pick their CI/CD process. And then you have 100 teams with 100 CI/CD approaches. And when you need to collect evidence for PCI certification or something like that, right? Good luck. It's going to take you 7 to 12 months, okay? So shift left without proper governance in place is dangerous. It is dangerous. That's why the idea of platform engineering that we're talking about here implies you do shift left. Shift left works, but you cannot do it in a chaotic way. You need to have proper governance in place, and that governance is managed by platform engineering. Essentially, your teams do own more. They do own the stack end to end, but they don't need to figure out everything on their own. It's based on the artifacts produced by the platform team. So the first step, right, let's get practical. First step would be, let's define infrastructure and application resources ownership model. Let's define tools. Let's define processes. And, we're not talking here about EC2 instances. We're talking about serverless, right? Because application developers want to own some of that, but infrastructure people, they don't want to lose control, right? So let's talk what that platform, is kind of look like. So let's build that platform for a serverless world. At the very bottom of that platform, you will have AWS, right? You got stuff that is running on AWS. That's the services we provide, management API, Lambda, Fargate, whatever you're using, right? That's kind of the baseline. On top of that, you need to make a decision, your organization needs to make a decision, what's the infrastructure as code, tool, framework that we're going to use? It doesn't have to be one. Right? Anyone here? Let's see. Terraform, CDK, awesome. CloudFormation, SAM. Okay, so we went with statistics. Our examples today are going to be primarily CDK and Terraform, right? So kind of, statistically, this is what the most people were getting here. Everything you see today is applicable to any infrastructure as code framework, right? It's just these two are quite popular in the serverless world. So pick a framework. If you want to use Terraform, if you're using Terraform in other parts of your organization, go ahead, continue using it, right? If you're using Crossplane or ACK, you manage your resources through Kubernetes control plane, continue doing that, right? Don't reinvent the wheel. On top of this, you have the CI/CD flow, right? Once again, you need to make a choice. Do you use GitHub, GitLab, code build? And you probably noticed that towards the left side, that's more AWS options. Towards the right side, that's more of a third party, our partners, open source, etc. Right? So every layer will have something like this. On top of that, you need to define what's the governance tools that are going to use, right? Why? Well, because since you're giving your developers freedom, and we'll be talking about that in a moment, you also need to have governance. There is no freedom in selection of tools without proper governance that your developers are actually selecting from approved list. And obviously on the very top, and this is not going to be the main topic for today, but still, you can have something like Backstage or Canoe or GitLab, something where you store your assets in, something that your developers can access. It can be something sophisticated as Backstage or something as simple as Git repository, right? Essentially something that your developers can use to obtain access to those resources. You'll have a bunch of partners, okay? So those are common one. I just arbitrarily picked 3 of them, right? So you'll have different partners that you need to integrate into your tools. And the question is, that's a lot of icons and a lot of layers. So how do you actually standardize this? How do you build what we call a blueprint, right? And this is where we're recommending you start with a catalog of vetted infrastructure as code modules, okay? Everything before this slide was hypothetical. It sounds awesome, right, in theory. Where's the practice? This is the practice. This is something tangible, right? Something that your developers can use. It's much more than a pretty slide that sells a great idea, right? This is tangible. So you're building a catalog of vetted IAC model. Depending on your infrastructure as code framework, it will have different names, like Terraform uses modules, CDK uses constructs, different frameworks, they have different terminology. But the idea is you identify what your developers need and you modularize that. So why? Big question. Well, the same reasons we're modularizing stuff, right? First of all, best practices. If you're creating something as a module, you can embed best practices into that implementation, and you'll see examples, don't worry. Reusability. If it's a module, you can reuse it across the whole organization. And the last one is composability. Once you have different modules implementing different functionality, you can start composing your architectures from these modules. So let's take a look at some code, right? Let's take a look at how this actually works. Terraform, right? So a lot of people raise their hands. If you're at this point thinking, this is one useless Terraform script, like Terraform configuration, you're kind of right at this point. We're going to evolve it, don't worry. Okay, so I got variables, function name, and runtime. We're talking about Lambda here. And then I'm creating a resource, and I'm just using function name and runtime as variables. There is nothing fancy here at all, right? I'm just using variables to define a resource. But there's one interesting thing here. If you look at the left side, variable runtime, the default is set as node 20. So with this one single line, I can standardize the default runtime across my whole organization. It's kind of basic, right? It's pretty rudimentary. But what you're doing with this single line is basically you're saying, my development teams, they don't need to make this decision. And this is just a simple example. That's the default that we've defined in our organizations. Let's evolve it. How about log retention days? Right? You know that default, you're probably familiar with that. The default retention for CloudWatch logs is forever. Okay? Forever means paying forever. Right? How about you standardize it in a module? Let's say 14 days. Again, arbitrary number, right? But basically, by creating this very simple approach, right, you're saying, well, by default, all the logs will be stored for 14 days and deleted automatically after that. Not a single person in your engineering teams need to know about it or worry about it anymore, right? Because that's the standard across organization. A few more examples. I want to standardize logging config. Because previously, every single team had different login structure, right? I think many of you can relate here, right? I want to standardize usage of Lambda Power Tools, right? So I want every single function to have a specific library embedded. Now my developers, they don't need to worry what's Power Tools, which version do I use, right? Do I get it through ARN or whatever other way, right? You just standardized it. Once you build this Terraform module, you can package it. Again, I'm using Terraform as an example. Ron will show CDK. We specifically use these two frameworks to show you it's not about framework, it's about the approach. So you've created a Terraform module. You called it My Awesome Enterprise Lambda Function or whatever you want to name it. You've defined what's the configuration variables, and that's something that your engineering teams can change, because obviously they need to specify function name and memory size, etc. But you've also defined defaults for many of these parameters, right? So for example, if it's a Java application, probably a good default will be 2 gigs of memory, right? But if it's a Python, probably half a gig would be just fine, right? For many of you, it sounds pretty basic, but once again, your engineering teams don't need to worry about this anymore. Can they change it? Of course they can. But do they have to know about it? No, they don't. That's the beauty of it. And you're also going to have some outputs. So those are 3 examples of very real composable modules that we see across many customers, including in Ron's company, right? We already talked about baseline Lambda function. So how about Lambda function with periodical scheduler? Anyone here implements this scenario? Lambda function with event bridge scheduler? Yeah, I see about 4 people. SQ with redrive, DLQ, redrive. So this is not rocket science. You'll probably already implement this in scenario. Those are 3 patterns that I've implemented as modules, Terraform modules, CDK construct, doesn't matter. How do I change these 3 modules into an architecture? This is probably the most important part of this presentation. Do you know what's the difference between 3 modules in architecture? This, 2 arrows, right? Now it's an architecture. Again, 3 distinct modules, architecture. Okay, obviously, I'm simplifying this a little bit, but now you can take composable components and build an architecture. So you can have, for example, analytics job that runs once a day, processes data, throws that into SQ, and you have a Lambda function processing the data from the queue. Every single component implements best practices provided by the platform team. Development team don't need to worry about what's the best practice for using specific runtime or whatsoever. You would put those modules somewhere in the repository, right? It's quite flexible. It can be Git. It can be whatever you're using internally. We see Git as pretty popular because, again, it's a tangible piece of code, right? So you would put it in some sort of repository, and your engineering teams will consume those modules, right? If you use something like Terraform Cloud or Pulumi, they provide explicit ways to distribute those modules, right? But the idea is your engineering teams consume those modules. Over time, since, once again, this is code, and you're talking about engineering teams, they start contributing to these modules. So it's not like you as a platform team now responsible 100%. No. You can have social coding exercise. You can go to your engineering team and tell them, you want an update? Give us a PR. Okay, and the engineering team can start contributing to that as well, right? You don't have to start from scratch. There are a bunch of open source repositories. Again, you'll get these slides like in 42 minutes, right? There are a bunch of open source projects that already implement modules, right, for various serverless components that you can either use as is or start building on top of, right? It's open source, so you can take it, you can take the part that you like and add whatever is missing, right? So completely up to you. What's next? So let's evolve this idea. So we talked about creating those modules. Let's evolve that into architectural blueprints, right? Let's build something bigger out of it. For example, right, I know my company. I've spoken to a few people in different parts of the company, and I figured out that this is a pretty popular pattern in my organization. API gateway, bunch of lambdas, DynamoDB. Anyone here using it? It's like probably one of the most popular patterns ever, right? So it's popular in my organization, meaning there are multiple teams that are using this pattern, and those teams are communicating with event-driven architecture using Event Bridge or maybe something else, SQS. So you have different parts that are doing the same pattern, right? And there is a mechanism to communicate between these parts. What does it actually mean? So these are the building blocks. Okay, what's missing? Arrows. arrows are as important as blocks. Because in serverless world, you define these arrows also with infrastructure as code. When you create event source mapping for a Lambda to read from SQS, right? So those arrows are as important as blocks because once again, you're responsible for defining those arrows, right? You don't just give URL to developer and it's completely up to you, developer to do whatever you want with that. It's also part of your architecture. Well, it's common, it's useful. My engineering teams would love to have this as a pattern. I'm going to call it a blueprint. This is my first blueprint, synchronous API with database, right? So whenever someone in my company needs to implement a synchronous synchronous API with a database, they can just reuse my module. And it will have all the best practices that I've implemented. Which best practices? Well, how about these? This is just like a small subset of what you can do when you're providing this thing as a module, right? As a platform team, you can pre-configure defaults, right, and enforce things for a lot of things on these resources. So now your engineering teams essentially getting that out of the box. Moreover, you can embed observability, security, best practices, et cetera, end to end. Ron will talk more about that as well, right? Again, few examples. How many of you ever experienced what we call orphaned resources? Resources that you have no idea who owns them, right? Oh yeah, that's like, I wish I had $1, right? How about you set default tags on that module, and now every single resource has an owner, right? And developers don't need to do anything, they need to know about it, right? Like what, 5 lines of Terraform code, right? Or CDK, CDK supports that as well, right? You standardize this. Another problem, right? Well, yeah, and then you can have development variables and production variables, basically injecting those values. How about you standardize your DynamoDB security? You saying that server-side encryption must always be enabled, TTL, right, must be enabled, point-in-time recovery must be enabled. How many of your developers are even aware of the fact that DynamoDB provides point-in-time recovery and they might need to use it? Now you've standardized it. Security. If you have DynamoDB as part of your module, right, instead of saying, well, I have no idea what's going to happen there, we're just going to give asterisks as permissions, right? Great. No, right? You can standardize that. So by default, put item, get item, update item, right? If your developers need more, they can update it, right? But by default, you scope down the permissions to what you think is saying kind of good selection. Okay. We spent like, what, 23 minutes, and I never mentioned GenAI, right? Let's fix that. Bedrock, right? This is something that your customers, right, your developers, your customers might be using, right? So it's another component, frequent component in every single architecture today, right? And everyone is looking for answers. How do I properly configure it? Like context size, which model do I use? What's the configuration for temperature, top P, et cetera, right? Everyone suddenly needs to become a LLM expert. Well, how about, first of all, you standardize security, right? It's part of your blueprint. You standardize that your blueprint has access to a specific model, right? So now your developers don't need to wonder which model do I use. This is what we use as a standard in our organization. Moreover, the configuration, max tokens, temperature, top P, is also standardized. Can your developers override it? Yeah, easy, right? Do they need to worry about that? No, they don't. That's the difference. This is actually interesting because this is the first time that you see function code, not infrastructure as code, but function code. That's a little bit different, right? So as infrastructure team, well, not infrastructure anymore, platform, right? As a platform team, are you saying that now, in addition to being able to kind of define that architecture with infrastructure as code, we can also enforce things in the actual application code, in the function handler, for example? And the answer is yes, right? So if you think about function handler, it has some business domain logic, right? Business domain code. But there are also some things which are not specific to a particular function, not specific to a particular handler, like observability. How many of you are embedding some observability extension, for example, right? Do you want your developers to worry about that? Probably not. The way you do config or secret management. Multi-tenancy, that's a lot of work that Ron and CyberArk did. Security governance, integrations, and SDK. There are things that are unique to this function, and that's handler. That's the business value that the function provides. But there are also things which are kind of more generic across multiple functions, and you can actually standardize that as well. And now you probably have a big question. But what if developers do want to make, right? I've just standardized everything with amazing defaults, and now I have a lot of developers coming to me saying, how do I override those defaults? Defaults are nice, but I need custom configuration, right? Obviously, it makes perfect sense. So like I said in the beginning, you do want to give your developers this flexibility. You do want to allow them to change things, but you want to allow them to change things within boundaries that you've defined, okay? We have this notion of various controls, right? So this is, in a nutshell, kind of the standard, again, generalized a little bit, right? The pipeline of your application code, right? It starts with you write your code and infrastructure as code, commit, build, test, package, deploy, run, right? So you have the phase where it's development, then you have continuous integration. This is where you build and test stuff through something like Jenkins, I don't know, whatever you're using. Then you have continuous delivery where you're actually pushing that to the cloud, right? At any point in time here, your developers might want to kind of change things. Well, customize things, right? They want flexibility because we started with flexibility. We provide this notion of proactive controls and detective controls, right? You're familiar with that? You've heard about that? So proactive controls, essentially controls that, proactive, right? They catch things before something happened, right? So for example, during the development phase, when developer changed something, you want to make sure that the change they made is safe, right? To give you an example, let's say in your organization, you want to define what are the approved runtimes. You want to say we only approve, like, again, arbitrary Node and Python, and only 2 latest versions, right? So whenever a developer decides, well, I'm going to experiment with Java, maybe, but at first they're going to get an alert saying, no, we don't do Java here. Okay, again, just picking on a particular language, right? It can be anything, right? And then you evolve that. So you want to have these proactive controls and detective controls at every single stage. Now, there are different tools to achieve that. Some of those tools are coming from AWS. Other tools are coming from other vendors. The choice of those governance tools heavily dependent on your choice of infrastructure as code tools, right? So if you're using CloudFormation, for example, you can use CloudFormation Guard. If you're using CDK, you have CDK NAG, amazing open source framework. If you're using Terraform, you got HashiCorp Sentinel or Chekhov. Anyone using these, right? So what do these frameworks do, right? That's a really good question. So those are the frameworks that I'm seeing pretty commonly. What do they do? Well, we'll take Chekhov as an example because we had a few examples of Terraform code. So Chekhov, it's a framework, governance framework for Terraform. So you can see here a list of controls that all of them are green. All of them have passed, right? That I validated before committing code. So this is part of my local development experience, right? This is part of my CI/CD process, right? So first, before code is actually committed, I run Chekhov and it validates that my code, infrastructure as code, is complies with all the rules that I've defined. And then the same thing happens during CI process. Now, what's going to happen if I'm going to introduce a change that is not compliant with whatever guardrails that the platform team supplied? Well, this, right? So you can see here at the bottom, ensure that CloudWatch log group specifies retention days, right? Well, because I accidentally deleted that property from my configuration, right? So now my logs are going to be stored forever, right? And ensure CloudWatch logs retains logs for at least 1 year. That's the default control that they have, right? So what it means is developer, right? They've made a change locally according to what they think they need, right? But that change, goes beyond what you think should be allowed, okay? So they do have flexibility to make those changes, but you control what's the kind of the range of what is allowed within your organization, right? To give you a few examples, anyone here ever used Lambda function running in Node.js with 10 gigabytes of memory? Right? Why is it less common? right? It's perfectly fine. But why is it less common? Because at 10 gigabytes of memory, you're getting six virtual CPUs. A node by default is not going to use 6 virtual CPUs, right? You need to write your code in a very special way for this to happen, right? So it's doable, it works, but you need to know about the fact that now you need to write your code in this specific way. So as a platform team, you're familiar with this, right? And you can write a rule that says if this is a node application, right, you can set memory up to 2 gigs, right? Why? It's a safeguard. Right, because you can set it to 10 gigs and you're going to be paying a lot, but not actually using that. And if you need to exceed that, let's talk. Right? Maybe we'll add one more property saying, I know what I'm doing, right? Something like that. But essentially, to summarize the section, do your developers have flexibility? Yes. Do they need to be aware of everything that's going on under the hood? No. The cognitive load on the development teams is significantly reduced. Right, so let's summarize the section, okay? Platform team, they build and maintain those blueprints. They put them in some sort of curated blueprint catalog, right? Developers consume those blueprints. Over time, developers provide feedback to the platform team, right? So platform team can evolve those blueprints. Think of it as a product. It's a product. It's not a weekend project. It's a product within a company. If everything works great, over time, developers start contributing to those blueprints, right? Because this is the way developers can get what they need faster, right? You know the process. You want it, we're happy to merge your PR. Over time, you can have security and compliance team and whatever other teams you have in your organization actually bring in their requirements. So now, developers don't need to talk to security teams, right? No one kind of enjoys that, right? We have to, but no one really enjoys that. You can bake this into the blueprints, the requirements from security, compliance, etc. teams. Now, I've spoken for, 30-something minutes, but I think you want to see how this actually works in production-grade huge system. So I'm going to pass it to Ron, and he'll tell you exactly that.
Thank you. Everybody can hear me? Yeah? Happy to be here. So before we start talking about platform engineering at CyberArk, I'm going to quickly introduce you to what we do at CyberArk. So CyberArk was founded in 1999, and we are the identity and access management global leaders. We have over 4,000 employees across the globe and over 1,000 developers, and we are a cloud-native, serverless-first SaaS company. And that's where I want to shift our focus to. Now, if we go back about 6 or 8 years ago, we had several SaaS solutions, but their experience was fragmented. From the developer perspective, we had multiple silos, so there was no unified developer experience, no tech stack, or even architecture. From the SRE perspective, again, multiple solutions, so again, it was harder for them to support all our SaaS solutions. And for the customer experience, which is the most important one, again, there was no unified experience. There was a different onboarding experience, and the look and feel wasn't all the same. So in 2020, we decided to do better. And we started our platform engineering team with 15 engineers, and I was one of those engineers. And our goal was to basically unify all these experiences. Now, fast forward to today, and we're actually able to do that. We've streamlined our tech stack. We're using AWS, Serverless, and Python. You have a unified observability stack, unified customer experience, onboarding, look and feel, and we've defined best practices for security, governance, and created multiple toolings. Now, these toolings are used by hundreds of developers, and we saved with them years of development time. And from our humble start of 15 engineers, we're now well over 100 engineers across 2 divisions. Now, our goal is basically to adopt and scale serverless across the organization. But we want to do it in a smart manner. We want to maintain standards and best practices for architecture, governance, security, and observability. Basically, we want to help our developers and the organization to deliver value faster for our customers. So what we've done is build a serverless platform. And this platform basically encapsulates automations and best practices into blueprints, like Anton has mentioned. And these blueprints are used by hundreds of developers. We've created dozens of services, and we reduced the new service time creation by 99%. That's not a typo, that's actually real, and we're going to see the numbers later on. And we're able to save years of development times and millions of dollars. So my name is Ron Eisenberg. I'm a principal software architect at CyberArk at the Platform Engineering Division. I'm an AWS Serverless hero and have a website called runthebuilder.cloud where I talk about AWS, serverless, and platform engineering. So over the years, we've created in the platform engineering multiple SaaS services, multiple SaaS products across multiple planes. For example, in the application plane, we've created our shell service, which is our UI, which loads all sorts of iframes for the different SaaS services that we have. And we've created an audit service, which is a centralized audit service that shows audits from all of our services. In the more traditional platform engineering plane, the control plane, we've created our tenant management service or the customer onboarding service, license services, and such on. And even in the data plane, we've created our centralized pub sub for service-to-service communications. But all of these services, they are built on top what I like to call the pillars of impact. Now, these can be SDKs, blueprints, automations across very important and critical domains: observability, security, governance, and automation and developer experience. And my goal in the platform engineering team goal is to help other teams at CyberArk, the other service teams, to build their services and use the same pillars of impact. So let's talk about scaling enterprise-grade serverless services. How do we build them in a grander scale? So this might seem familiar because this is actually what we're building. When we start a new serverless service, we start with the backend service. And this is exactly what Anton was showing a couple of minutes ago. We have some CRUD API over some entity. We have an API gateway that invokes a set of Lambda functions that read and write from a DynamoDB table. But I did mention that it needs to be enterprise grade, right? So now we need to think about all of these elements. Infrastructure as code. I need to write my CDK code with all the best practices to spin up all these resources. I need to have my pipeline take me from PR to production through multiple gates, multiple environments, dev, test, stage, pre-prod production. These are different AWS accounts in our case. And even multiple regions. We deploy to dozens of regions. Then you have Lambda best practices, hexagonal architecture, input validation, tenant isolation libraries that we've created at CyberArk. Then you have testing, unit test, integration test, end-to-end test, observability. We have numerous observability libraries. So it's a lot of work, right? And this is a very simple backend microservice. But it doesn't stop there, because we also need a user interface. Think of this new service as a single web page application. You have a table that shows items from the backend. You can read, write, and change the items. So we're going to add the cloud for distribution. We're going to add our S3 bucket with the static React files. But again, we need all the best practices, infrastructure as code, our CI/CD pipeline, our front-end best practices. We need to think about input validation, our integration with the backend, error handling, accessibility, testing, localhost testing, Cypress, Playwright implementations, and even telemetry. We're using Mixpanel, so now we need to add our Mixpanel SDK, so we know what our customers are doing in the UI, so we know which feature we want to implement more and expand and which we can drop. And I did mention that this is a SaaS service, so it gets even more complicated. So now we need to integrate with our SaaS control plane. And at CyberArk, that means we need to integrate with the tenant management service. We need to have our own subdomain for our service, our own host name and certificate for our customers to send our service API requests. And we need to have cross-account access. Maybe we have some SQS that needs to subscribe to an SNS topic in a different account. Or maybe we need to do role delegation and assume a role in another account to access an IAM-protected API gateway. These are things that we need to do out of the box. So what I'm trying to say here is that enterprise grade is complex, it's complicated, it's a lot of work. One microservice is just not enough. You need multiple of them, right? You need to integrate with other SaaS components. You need to deploy to multiple AWS accounts, dev, test, stage, pre-prod, production, multiple regions. And you need to do all of these by following serverless and enterprise best practices and libraries and tooling. So before we had our amazing automation and tooling, we saw from surveys and estimations that it would take a senior engineer about 5 months or 20 23, 25 weeks to implement these microservices with all the tooling and all the SDKs and all the best practices out of the box. But now that we've created our automation, it takes about 3 hours, just 3 hours. So let's see this automation in practice. Let's see the developer experience. So our goal is to build a new service, the one-click service. And it's going to have our CRUD API, all the best practices, our front end, the CyberArk unified UI, the look and feel. And we want to connect it to our SaaS control plane right out of the box. So all of these things are going to be part of our new service. So for us, it always starts with the developer portal. For those who don't know, this is Port. We're using it. It's a SaaS service that we integrated with. You go to self-service in the top, you click, and then you choose create new business service, and you have this form. So now you need to choose your service ID in the SaaS control plane, your service name that appears in the customers in the UI, your name, your GitHub organization, and things like that. And then you click on Start. That's where the magic happens. And then 3 hours later, you're greeted with new components and integrations that are provisioned. We have 6 new GitHub repositories that we scaffolded and deployed to AWS. And now, all that it takes is to create a new tenant with our new service and log in as the customer and see the new service in action. So here, we can see the new service in the CyberArk UI. And you can see on the left, we have the application picker, our SaaS application picker, and we have our new service with the default icon. But here in the middle, we can see all the items from the backend. So we fetched all the items from our DynamoDB table. So it works, our integration works. And even in the title where you can see FF enabled, that's actually a feature flag that we got from app-config via the backend API calls. So what did we see? So we saw 6 blueprints. They have all these best practices, security, observability, all these tooling that are baked in. We have our front end, our back end, our feature flags configuration, our CloudFront distribution, our tenant management integration, etc. And these are all deployed to 4 different AWS accounts: dev, test, stage integration, where integration we deploy to 2 regions out of the box. Now, from the developer perspective, that's amazing, because now they get all this heavy lifting out of the box, and they can focus just on the business domain. They can take what we built, what we gave them, and just expand on that. As Werner says, go build. Now, these are some basic automation developer experience tips from our use cases. Your automation needs to be simple to use with minimal prerequisites. And I cannot stress this enough, minimal prerequisites. Otherwise, people will get it wrong, get confused, get very frustrated. It needs to be retriable because people do make mistakes. It needs to be customizable because one blueprint will not fit everybody's needs. And you need to have the ability to delete failures. You also need to have ongoing maintenance on all the blueprints, but not just a single blueprint, but the entire process. You need to create all these one-click services from time to time, so you can see that this process runs from the beginning to the end. So now I want to talk about architectural blueprints, which are a different type of blueprints. So as Anton mentioned, we're using CDK Python. And in this example, we're creating a Python library that contains CDK constructs that encapsulate these black box architectural patterns. And these are versioned. We have GitHub pages, so we document them, and we have release notes around them. And they're easy to update and use. So a few examples. We have our Lambda function with dynamic provision concurrency, meaning the provision concurrency setting goes up and down according to traffic shifts. We have a secure S3 bucket, which is basically a bucket that our security architects gave us the thumbs up on it, on its configuration. We have the classic SQS and data queue. You got to have those. We have our CMK and KMS, where we can sign and encrypt messages. We even have a DynamoDB table that works seamlessly with our tenant isolation library for idempotency use cases. And we have our WAF ACL association that knows how to connect to our WAF that came from our firewall manager, from centralized firewall manager. So this is an example of actual code. This is code that I copied from one of the constructs. It's a very simple construct. It's our S3 bucket that we use across the organization. So you can see that in line 13, we enforce the SSL communication. We set a removal policy to retain in production environments because we don't want to delete our customers' data by mistake. We block public access and we enable encryption. It's very effective, and all of our developers can use it across their services. Now, it's 2025, and things are changing, as you've noticed, and also the platform engineering domain is also evolving. Now, if you recall this diagram from before, I'd argue that now in 2025, we need to add another pillar of impact. Yes, it's agentic AI. Now, let's think about the following problem, and this is a real problem that we had. So we have a requirement for three of our developers from different services to build an MCP server and to expose their service API through that. Now, it might be fine, but what's the problem here, right? So the problem is that they need to reinvent the wheel, basically. It's a new world, it's a new domain. They need to think about authentication and authorization, and they're doing this all in parallel, right? CDK, they need to write the CDK. They need to write the CI/CD pipeline. They need to learn how to test with MCP clients to figure out observability. So this can cause duplicated efforts, architectural inconsistencies, and maybe even tech debt. But there's a better solution, a very simple solution. Let's use platform engineering blueprints. So this is something that I actually had the pleasure of writing and open sourcing, by the way. So we have our own MCP server blueprint. We have our Amazon API gateway with a WAF connected to a Lambda function that runs the Lambda web adapter extension. We run the Python fast MCP server, and then we have some examples for MCP tools and resources that our developers can use, extend, do whatever they want with them. But on top of that, you get infrastructure as code, CI/CD pipeline, security best practices for this new domain, testing, and observability. So now, for our developers, they can just scaffold this blueprint and create their own new MCP server. And that's great. They get all these toolings out of the box, and it's easy to use. Back to you, Anton.
Thanks, Ron. Thanks. All right, yeah, so you saw a real-world implementation, right, of what these practices look like. You probably noticed that it takes time. It's not perfect, it's not something you do within, a few days, right? It's a process, you evolve over time, you add more functionality based on what your consumers, your development engineering teams are looking for, right? So some best practices that we've seen as very efficient when adopting this approach. Don't boil the ocean. Right? Do not say, I'm going to solve all the problems in the world with my blueprint. Identify a problem that is, the most impactful in your organization, right? API gateway, Lambda, Dynamo. Like 70% of teams are using this. Let's standardize it, and let's provide flexible customization for that, right? Identify what you can solve realistically, not something that will take 2 years to implement, right? Solve that problem, measure success, evolve. Iterate, right? You'll probably notice it sounds like building a product, because it is, right? Don't treat it as a weekend project. It is a product. You've noticed like over 100 people working on this, started with 15, over 100 people are working on this now, and they're saving years of development time for the whole organization. So focus and prioritize, right? Don't spread yourself too thin. One size doesn't fit all workloads, right? Obviously, your amazing blueprint will immediately get feedback from engineering teams. No, we cannot use that for whatever the reason is, right? Trust me, it's going to happen, right? Listen to this feedback, ideally collect it early, right? And make sure that you address it and you provide customization, right? So for example, your teams, they want to be flexible on the runtimes, cool. They want to be flexible on TLS configuration, awesome. Right? Collect that feedback and implement it into your blueprints, because there's never going to be a product that is suitable for 100% of consumers, right? I'm not familiar with such a product, but try to cover large scope and make your blueprints customizable. Documentation and education are key, right? So you're building a product for people to consume, right? Make it easy to consume, right? Dropping a piece of code on GitHub and saying, go clone it, that's not good enough, right? It might be good enough for a very small part of your organization, but if your engineering teams need to invest more time into understanding your blueprint than building it themselves, that's not gonna work. Make it easy to consume, set up education sessions, right, in your organization, right? You're building a product. You need to prove the value of that product, right? Is this approach working, the blueprint? Yes, it does, right? We have examples, right? But you need to make sure your organization is educated and they know how to use it, right? The good thing is generating documentation with GenAI today is really, really simple. This is probably the most important thing, right? If you believe in we're gonna build it and the users will come themselves, well, no, right? Build with your customers, right? Before you start building, validate that this is actually solving a real problem, right? Don't try to talk to every single team. Again, don't boil the ocean. Find a small subset, go to them and say, hey, I think I have something that you will benefit from, right? And we can work on that and start kind of solving your problem. So build with your customers. In this scenario, customers are the engineering teams that you as platform engineers are trying to help, okay? These are the general best practices that we've seen that actually work quite well when starting to adopt this approach. So with that, we have several other sessions that we'd like to recommend. Some of them are actually in the past, but it's all going to be on YouTube. Okay, there's one, on Thursday, right? If you're not familiar with Serverless Land, right? Anyone here familiar with Serverless Land? This is a website our mostly developer advocacy team maintains. It has a lot of templates, blueprints, tutorials, right? Hundreds of things that you can use. Right, so I highly recommend you explore that one. We have weekly office hours on YouTube and Twitch, so there's a lot of good information there. And me and Ron gonna be right here if you have any questions. We're not gonna run away. We're happy to take any of your questions once we're done in about 30 seconds. The last thing I promised is giant QR code with everything you saw today. Source code, slides, everything, right? Videos, etc. Don't forget to complete the survey in the application, and we hope this was helpful.
Thank you.